Today we're looking at notes 8-4, factoring continued. So today we're going to use factoring to find all roots of each polynomial. So looking at number 1, looking at this first polynomial here, we have 0 equals x cubed minus 64. So when I go to factor this, I would have, because this is a difference of perfect cubes, I would have x minus 4, close parentheses, and then x squared plus 4x plus 16. So now what I have here is I have a linear factor and a quadratic factor. This linear factor, you probably already know and can see that my 0 from this factor would be x equals 4. This, however, quadratic factor needs to be either broken up further or we need to use quadratic formula, something to extract the two roots that come out of this. So if I were to factor further, I would be looking for numbers that multiply to 16 but add to 4. If you think about it, numbers that multiply to 16 but add to 4, that's non-existent. There's no such numbers. So unfortunately with this quadratic here, what I'm going to utilize to find the zeros from this is quadratic formula. So x equals opposite of b plus or minus square root b squared, so 16, minus 4 times a times c, all over 2a. So, going a step further, negative 4 plus or minus 16 minus 64 all over 2. So then this would become negative 4 plus or minus square root of negative 48 all over 2. So off to the side here, I'm going to break apart negative 48 under the radical, so negative 1 and 48. 48 is 6 and 8. 6 is 3 and 2. 8 is 4 and 2. And then, so drag down the 3, drag down the 2. 4 is 2 and 2, and 2. So here I circle my pairs, as well as circle that negative 1. All of that can come out. So I would have x equals negative 4 plus or minus 2 times 2 is 4. The negative 1 comes out as an I. Square root of 3 is the only thing left. All divided by 2. So then when I look at this, I notice it can be simplified here. Both of these terms can be divided by 2. So I would rewrite negative 2 plus or minus 2i square root of 3. So my roots for this polynomial are negative 2 plus or minus 2i radical 3 and x equals, from this factor here, 4. So and that makes sense because, let me box this first. Going back to the problem, this was a cubic. That tells me there should be 3 roots. I've got 2 here, the plus root and the minus root, and then 1 root here. So I have 3 total roots for this third degree polynomial. Okay, moving on to the next polynomial, I have x to the 4th minus 12x squared equals 64. Obviously I want to get every single term on one side of the equal sign. So I'll move that 64 over, make it minus 64. Okay, I'm going to try to factor. I notice right away it's a 4th degree polynomial, so that means I should, in my final answer, get 4 roots. So when I go to factor this, I'm looking for numbers that multiply to negative 64 but add to negative 12. So that's actually going to be negative 16 and positive 4. Okay, and then you have 2 options here. You can, since knowing this is a difference of squares, this is a sum of squares, you can break this up further, or because of the way these factors worked out, you could right away set each of these factors equal to 0. Okay, and then x squared plus 4 equals 0. And I'm going to show you both ways and how they both work out. So here, if I do this, I move the 16 over, it becomes positive. Okay, I square root both sides. I get x equals plus or minus 4. On this one, I move the 4 over, it becomes a negative 4. I square root both sides. This becomes x equals plus or minus 2i, because the negative inside the radical there. Okay, so these are my 4 roots. X equals plus or minus 4, and x equals plus or minus 2i. What I want to show you, I've got my 4 roots here, which makes sense, 4th degree polynomial. What I want to show you is this might be your option that you choose, or instead of doing this right here, what you might have seen is that's a difference of squares. You might have known that separates to x minus 4, x plus 4. And this is a sum of squares, so you should remember that a sum of squares means you're going to have x plus 2i, x minus 2i. So if you would have either gone from here and set each factor equal to 0, these would be the answers you get. Or if you would have gone further and factored, you would have gotten the same answers, because x minus 4 equals 0 produces x equals 4. So that's that. X plus 4 equals 0 is x equals negative 4. That's that. Then here this would have been x plus 2i equals 0, x equals negative 2i. And this right here, x minus 2i equals 0, would give you x equals positive 2i. So nonetheless, either way I do it, I get the same answers as these. It's just to each his own. Which method do you prefer?